Alright, so we're going to do an example of solving a system of two equations and two unknowns by um, a substitution method. So we're going to look at 4x plus 3y equals negative 13, and another solution, x plus y equals 5. And we're going to do this by the substitution method. And so the goal here is to solve for one of the variables in one of the equations and plug it into the other equation. 4x plus 3y, they have coefficients of 4 and 3 on those two variables, so it might be a little bit harder to solve, and then you have to deal with some fractions, so it might be a little bit easier to go after that second equation. Negative x plus y is equal to 5. So if we add x to both sides, we will have y equals x plus 5. And so what we're going to do is we're going to take the 4x plus 3y, and instead of putting a y, we're going to replace y with an x plus 5. And so now it's just an equation, one variable. We'll go ahead and distribute that 3 through, and go ahead and solve it from there. So 7x plus 15 equals negative 13. And what we'll go ahead and do is subtract 15 from both sides and get 7x is equal to negative 28. And divide both sides by 7, and we'll have x is equal to negative 4. And at this point in time, you got one of your answers, so you can go back and plug it into the first equation or the second equation. It doesn't matter, you're going to get the same answer. The second equation looks a little bit easier, so we're going to plug negative 4 in for the negative x plus in the negative x. Now remember, there's a negative sign that comes with the formula here, and so I had a little bit of trouble fitting that in there. So negative 4 plus y equals to 5. So the negatives cancel, and we have 4 plus y is equal to 5. So the y is equal to 1. And then we'll go ahead and abbreviate this. Point of intersection is negative 4 comma